Hello, welcome back to my video. I didn't upload my video for a few months because my uni started, but now my exam is finished, so I will be uploading video from now on. And if there are any particular questions that you have encountered in the past year that you wish me to solve, I will be solving it for you, and I will upload the video and the solutions within a few days or as soon as possible. So today, the question we'll be looking at is this interesting question that I found in the past year. It's from 0606, the additional mathematics, 21 May, June. It's a past year from 2015, and then the code you can see in the video title. So this is actually a very typical question that you will always see in the past year, no matter which zone or which year you are sitting the exams. So the diagram shows a circle, center O, radius xcm, and then points P and Q lie on the circle. The line PT and QT are tangents to the circle, and the angle POQ is equals to 3 pi over 4 radians. So there are a few keywords you can see here. That P and Q lie on the circle, and then PT and QT are tangents to the circle. So you might have learned it in class that if it's a tangent to the circle, the angle between the tangent and the radius of the circle will always be 90 degrees. So immediately you have to note down that these two angles are 90 degrees. So when it's related to a right angle triangle, because of the 90 degree, you might wish to also immediately write down whatever that you have known about how to solve a right angle triangle. And you might wish to memorize this. This will really help you because the examiners like to test you on this kind of knowledge. You need to make sure that you remember that, for any right angle triangle and any angles, no matter here or here, the angle, the line that's opposite of the angle, we call it opposite. And then the longest line is always, we call it the hypotenuse. And then the adjacent one, which is the angle that stick to other than the hypotenuse, we call it the adjacent. Yeah. And then to use cos, and then when to use sine, and to use tangent. Remember it, and then write it down on the exam in your paper. And yes, you can write your notes in your exam paper. You won't deduct your marks. Okay, so and then another point we have to notice is that the angle that they give you is in radian. So in another word, you have to always switch your calculator. I'm gonna show it here. Switch the mode to radian. Not sure if you can see. Okay, you can see. So on your calculator, press shift, press mode, and then you find that there's a radian over here. So you press 4. So your calculator right now assumes that the angle that you key in will be in your radian. In another word, you can directly key in 3 pi 4, and then they will give you the corresponding length of the line. Now, we are all set. So we look at our first question. Find the length of PT. Immediately, this is an application of the things that you have written down. So you notice that PT here is actually the opposite of the right angle triangle if you have drawn a line here. So you might wish to note down that this longer line here is the hypotenuse. And then because the angle that we have will be this part, so that the length, the side that's opposite to the angle, we call it the opposite, so label it O. And then the side that is stick to the angle, we label it A. So PT is O. So in order to find O, we have two choices. Given that we have hypotenuse, or we have the adjacent side. And in this case, it's the adjacent side that we have. So immediately, we know that we have to use tangent. And then notice that we don't use 3 pi over 4 because this is exactly half of the angle that we have over here. So make sure that you remember to divide it by 2. And then to press it out on the calculator, it's pretty straightforward. So you might wish to first key in the first line over here that you've written down, divide by 2, and then you get 3 over 8 pi. And write it down. Remember to label it as radian. After that, you may wish to key in, to find PT, you may actually want to also rewrite it as PT equals to 8 multiplied by tangent 3 pi over 8. And then all you have to do is just to key in 8 multiplied by tangent 3 pi over 8. So I'm going to do it now. 8 multiplied by tangent 3 pi over 8. And then you will get the answer 19.3. And then write down your 19.3. It has a lot of decimal place, but if you read the first page of your exam paper carefully, you can actually just round it up to 3 significant figure. So this will be the correct answer, and then you will get all your 2 marks for this part of the question. Oops. Find the area of the shaded region. So notice that the shaded region is actually the area of these 2 right angle triangle together minus the area of this part, this sector of the circle, the white part over here. And as you can see, ignore this part first. So remember that your teacher might have taught you that to calculate the area of any sector, as in any part of a circle, the formula is just half multiplied by the radius. The radius we given here is 8 cm, and multiplied by the angle that you wish to find, angle of the sectors that you wish to find, that you already have, in order to calculate the area of this sector. But remember that your angle over here need to be in radians. And then luckily we have our angles, which is given to us. It is in radians. So we can just immediately substitute 3 pi over 4 into here to calculate the area of this sector of this circle. So the formula that I have written down is actually pretty straightforward. So first of all, we calculate the combined area of these 2 right angle triangle, which is 8, the bottom, multiplied by PT. So it's actually base multiplied by height. The formula for any triangle, I might as well just written down here just in case. So given we have a right angle, 90 degree over here, we call this the base. And we call this the height of this triangle. And then the area is always base times height multiplied by half. So this is how I got this part so far. Base times height, PT, multiplied by half. But because we have 2 triangles here, so I multiply by 2 again. And then I'm going to minus the part that is not shaded, which is the sector area, which is the area of the sector over here. So again, we use this formula, half multiplied by radius squared, multiplied by the angle in radian, which is already given here in radian as well. And then if you press the entire things in the calculator, you'll be able to get 79.1. And this is round up to 3 significant figure. Then you'll be able to get all your 3 marks over here. Then we move on to the third part of this question. Find the perimeter of the shaded region. The perimeter simply means that the outline over here means that you have to find all this line that is enclosing this shaded area. In other words, you have to find the combined length of PT, QT, and PQ, this curve over here. And as you can see that PT and QT are actually the same. In other words, we are going to be using back this same PT, this expression. Notice that when I multiply PT over here, I did not just use 19.3 because using this formula here, by writing it down and using this to multiply by 8, you'll give me a more accurate answer. So I think it's always good to be a bit less lazy during the exam, and then to get an answer that's as accurate as possible. So here I'm going to remind you again, the length of this sector, this part that I highlighted, we have this formula you might already know. It's just simply the radius multiplied by the angle. So it's pretty straightforward. Again, the angle here must be in radian. And we have our angle in radian. We also have our radius A. So in another word, we can find the curve over here. Now we have both the PT. PT, I just simply 2 multiply by PT because PT and QT are the same. I just need to times 2. So PT multiplied by 2 plus 8, which is the radius, multiplied by the angle given. And then I will be able to find the final answer as 57.5 cm. Again, this is also round up to 3 SF, 3 significant figure. Don't forget to label your units. Parameters and cm is calculating the total length, including the shaded area, and then area, make sure it's in cm square. And then the length of PT is also the length, calculating length, so make sure your final answer has the unit cm here. And this is how you solve this question in the exam.